Hello, I'm Ellie for Edu for Java, and this is tutorial number 5 of Android game programming. We're going to see some more of sprite and speed. If you remember, we had seen something of speed here. We are going to see also some animation. We are going to see how to use these graphics. In the last tutorial, we had put an animation. But the animation always seems to go walking to the left, and when it goes to the right it looks as if it was Michael Jackson. How are we going to do this? The first thing we're going to do is, as well as the speed variable x, we're going to put a speed variable y, and here we are taking care of the x borders. Let's take care also of the y borders. Let's copy the code from here. Don't worry, because I will explain this now. Let's replace for this code here. It's similar but a bit more compact. Shift Ctrl F to tidy this up. This is the same as before. The difference is that everything is just in one if. I wrote both, and instead of putting -5 or 5, I multiplied by -1. I put minus what there was, so if the direction is positive it will change to negative, and if it's negative the speed will be positive. If there is 5 in this side and it goes into a border, it will convert to -5 and it will go on the opposite direction. And with y we do the same. The margin controls are just the same as you can see, but in the same if. Okay, let's try it. As you can see, it starts with a speed of 5 in x and 5 in y, so it walks in 45 degrees. It bounces back here in x, it goes to -5, it bounces back here. See? Every time we run it, it's going to do the same. To do it a bit more interesting, we can make the speed randomic. It will be randomic this way. Let's add these lines. Random was explained in my tutorials before, so I hope you know it already. And what we do is modify these variables. They were initialized to 5, but now they are initialized automatically. Shift Ctrl O for the imports, so that random is imported. This is going to draw lots for numbers from 0 to 10, and it's going to subtract 5. We are going to get a number between -5 and 5. Speed can be between 0 and 5 for x and between 0 and 5 for y. Both positive and negative. Okay, let's try it. See, here it started in 0 for x, because you can see there is no lateral movement, and 5 for y. Let's try to run it again. This time it was 0 in y. Well, strange numbers are coming out. Here we have speed of x and y, but it doesn't get to 5. Unfortunately, this is the end of the easy part. Now we're going to learn how to manage animations. We are always using the animation left 1. This is because we wrote to always use 1. As we see in this graphic, we don't always want to use number 1. For example, in the direction x speed and y speed is 2 and -4, the real direction would be this one. This one. So we should be using this one, which is the number 3. If it is -3 and -1, minus 3x speed and -1y speed, we should use this one. If it's 4, 1, we should use this one, which is number 2. And if it's something like this, we should use this one. The question is, how do we, for x and y, know which one do we have to use? 0, 1, 2, 3. We need a function which will have as parameters x speed and y speed, and as a result 0, 1, 2, 3. 0, 1, 2, 3 corresponding to which one should we use? We use to create this method I looked at, math.attend2, which returns the radio in radians. It gives us the angle. Basically, this function is to any x, y, it gives us the angle. For example, here it would give us this angle here. We have to take into account that we are using in the screen axes different to the mathematical ones. This x-axis is correct, but this y one is upside down. If you can see it here, this is how it would be in a mathematical way. X and y would go upwards. What does it mean? When y increments, it will be go upwards, and here it goes downwards. Then let's go back to attend2. Attend2 gives us the angle from this point, from here. Here it would give us 45 degrees. Here 90 in radians, p over 2. Here it would be p, and this way, for example, the point is over here, it would be this angle that it's negative, till p over 2 and minus p. If we make an analysis of what we want to get when we have 0 and -1, we want to have up. When we have 1 and 0, we want right. When we have 0 and 1, we want down. And when we have 0 -1, we want left. Here I've made a table. To make it a bit more clear, here we have what I have just said, the up with each one. What I did was, with these numbers, I tried attend 0 and 1 just to have a reference. Here the result is p. We know that p minus p, they touch. They are the same. When we get near with positive or negative, we end up here. In right, it was p over 2, 0 and 1. If I divide this function with p over 2, the results are going to be between 2 and -2, going through 1, 0 and -1. For up is going to be 2 or -2. For right it is going to be 1, for down 0, and because I need an index to go from 0 to 3, what I did was to sum 2 to get rid of the negative, which give me problems. Here I have a number from 0 to 4, going through 3, 2, 1. With the up, we had seen that it was both the 4 and the 0, and as I want a number between 0 and 3 and not between 0 and 4, what I do is module 4. As a result of this, both 0 and 4 are going to give me 0. 4 module 4 is 0, and 0 divide module 4 is 0. Here I got a number between 0 and 0, 1, 2, 3, which were the numbers I wanted for the index. These numbers aren't really the numbers I wanted with these. What I did was I function, I do all this I told you in the table. I calculate math.attend2, I divide it by I divide it by p over 2 and I sum 2. This gives me a double. To this double I round it off. I round it off so it comes near the numbers. Do you remember that here I wanted, okay, if they were near here, they come near here. So I do it by rounding off a number. As this is number 1, all the ones which are near go there. All which are near this one will go there. The rounding off makes them go near, and then I do the module for the number of rows, in our case 4. The result of this gives me a whole number between 0 and 3, so that they match up. As we had seen here up is going to result here in 0, but the up I need is 3. This is the one which goes up. What I did is I used a small array and I did a small mapping. In the position 0 I put a 3, which is what I want. In the position 1 I put a 1, which is what I want for up. In the position 2 I put 0, and in the position 3 a 2. Okay, here's the resulting code. You have this function. Let's copy it here. Okay, this map here wants to create constant. Let's copy the map from the same code. I'm going to get the comments too, and lastly we have to substitute here, instead of the one which I had shown you, instead of 1 we're going to call the function we have created. Okay, let's run it. Here you see it, very happy, walking downwards. Let's see when it gets to the border, if it recalculates the direction. Perfect. Let's see another animation if it goes in another direction. As this one has the angle nearer to the horizontal, it is taking the animation which goes to the right. Here it bounces back and takes the animation which goes to the left. Okay, this is the most difficult tutorial I've ever done. I hope somebody has understood me. In any case, thanks for coming so far, for the people who got here, and see you in the next tutorial. Bye.